Alright, Assalamualaikum warahmatullahi wabarakatuh, and very good day to everyone. So today we're going to discuss about question on chapter rotational of rigid body, and this question is taken from a tutorial question, and we will start with question number 1 first. And the question number 1 said that the tub of a washer goes into its spin dry cycle, starting from rest and reaching an angular speed of 5 revolutions per second in 8 seconds. At this point, the person doing the laundry opens the lid, and as we know, and after that, the safety switch turns off the washer. The tub slows to rest in 12 seconds. Through how many revolutions does the tub turn during the entire 20-second interval? So if we read the overall question, there's a lot of things going on. So for the first step is we try to take out all the infos, okay? And then kita akan tengok sama ada macam mana dia punya flow soalan ini, and then baru kita akan plan macam mana kita punya solution, okay? So start from the first sentence, disebut it start from rest. So from rest, which mean kita punya angular speed start from omega is equal to 0, number 1. And the unit for that is I'm going to put as revolution per second. And the reason I'm using revolution per second is not in degree per second or in radian per second, sebab soalan ini provide kita punya angular speed dalam revolution, and plus soalan kita tanya juga how many revolution in the end. So I will going to stick with revolution, and then from there it said that the speed somehow increase. So from rest, and then dia menjadi speed yang seterusnya, which is 5 revolution per second, and that change take time about 8 seconds. So I'm going to put delta t is equal to 8 seconds. And then after that, after it reached angular speed of 5 revolution per second, the person somehow open the lids and then finally come to stop or rest in 12 seconds. Okay, so next the change will be from 5 revolution per second to rest, which means it goes back to omega is equal to 0 revolution per second, and that change take about 12 second. So daripada soalan ini kita akan nampak flow soalan ini, okay, dia ada dua kali perubahan. Satu daripada kosong pergi kepada 5 revolution per second, and then daripada 5 kepada kosong, dan dia mengambil masa yang berbeza. So for that kita akan apply gunakan kita punya angular kinematics, dan kita akan gunakan untuk kedua-dua part. Okay. So untuk memudahkan kamu, the first change saya akan letakkan dia sebagai first part, and then change yang kedua saya akan letakkan sebagai second part. Okay, so first kali saya akan start dengan first part, which is the change from 0 to 5 revolution per second, and the time is equal to 8 second. So equation kinematics mana yang kita akan guna untuk soalan yang pertama? Okay, so since kita ada omega, and this one I will call as initial. Okay, initial. This one is initial, and this one is final lah. Okay, and then we have t, which means kita boleh gunakan equation, menggunakan equation omega final is equal to omega initial plus dengan alpha, your angular acceleration, and then you times with t. So this one I'm going to put as number 1. So we know that the angular acceleration yang kita akan kira kemudian will be for the first part lah. Okay. Alright, kemudian kita masukkan value. Final is 5 revolution per second. Macam saya mention tadi, saya akan stick dengan kita punya unit revolution per second. Initially dia adalah kosong, plus dengan kita punya angular acceleration untuk first part, and then t kita adalah sebanyak 8 second. Okay, so from there kita akan dapat nilai angular acceleration untuk first part will be equal to, so kita akan dapat dia sebanyak 0.625 Okay, the unit will be revolution as well, but this is acceleration, so it will be second per second square. Okay, once we have the angular acceleration 0.625, then I can use that to find the revolution. Okay, so the revolution, which means we want to find what is value in theta or the angle. Okay, so I'm going to use the second equation, which is omega final square is equal to omega initial square plus 2 alpha for the first part, and then we have our theta. Okay, and this theta is for the first part as well. So masukkan value, kita ada 5 revolution per second square, 0 square plus 2, your alpha is 0.625, and then we have theta for the first part, and that theta for the first part will be equal to 20 revolution, or we'll just put as 20 revs. Okay, so that is for your first part. Now we're going to calculate for the second part. So after it reached 5 revolution per second, and somehow the lid is open and the angular speed somehow decreasing, and then finally it becomes stop, and that change from 5 to 0 take place about 12 seconds. So this will be another kinematics equation, which is angular kinematics, and I'm going to apply the same equation. Okay, so first kita akan cari dia punya angular acceleration. So omega final is equal to omega initial plus alpha, your angular acceleration, but this one is for second part, and then we have t. So final somehow becomes stop, initially is 5 revolution per second plus your alpha, this is the value that we are after, and then the time taken for this one is 12 seconds. Then from there I will have my angular acceleration for the second part will be equal to, okay, so you can see for the second part somehow the angular acceleration is become negative, so it will be negative 0.417 revolution per second square. Okay, and the reason why the answer or the value is negative because somehow the angular speed is decreasing from 5 to 0. Okay, next we're going to find what is the revolution for the second part, and I'm going to apply the same equation, which is omega final square is equal to omega initial square plus 2 alpha for the second part, and then your revolution. Okay, and this is also for the second part. So we're going to insert the infos. Final angular speed will become 0 square is equal to 5 square initial to your second part of your angular acceleration 0.417, and then theta 2. So from there I will calculate my theta for second part will be equal to 30 revolutions. So now I have theta 1, which is from the first part, and theta 2 from the second part. Now we're going to add these two because the question asks how many revolution for the entire 20-second interval. So total revolution will be revolution from the first part you add with revolution from the second part. So first part we have 20 revolution, you plus with second one, which is equal to 30 revolutions. So the whole or the total revolution for that 20-second interval will be 50 revolutions. Right, next we're going to discuss on question number 3. So question number 3 said that a flywheel is rotating at 100 revolution per minute. Okay, slows down at constant rate of 1 radian per second square. So question A, calculate the time required to stop the flywheel. So the question asks, what is the time to stop? And then calculate the number of revolutions made by the flywheel before coming to rest. So question B asks about how many revolutions, so that will be theta. But before we answer the question, we need to look at the infos that given and make sure that they share the same unit. What I mean by that is, if you see over here, the initial angular speed is recorded in a revolution per minute. While the this one, radian per second square, this is your angular acceleration. Okay, so it starts from 100 revolution per minute. So here I will put as omega initial is equal to 100 revolution per minute, and then slows down, okay, until it stops. So I will say that my omega final will be 0, okay, revolution per second. And then that constant rate, 1 radian per second square, that will be our angular acceleration, which is slowing down, which means the value should be negative. And then 1 radian per second square. So you see that all the infos, omega initial, omega final, and also your angular acceleration, they are not share the common unit, especially when you look at the revolution and also the unit for the time. This one is minute, this one is second, and this one also in second. So we need to standardize them before we can calculate. Okay, so first we need to decide. So for this one, I'm going to decide to use revolution unit for your angle, and also for time I'm going to use second. So this omega I, or your initial angular speed revolution, we will stay with revolution, which means I need to change or convert this minute into second. And to do that, so omega initial is equal to 100 revolution, okay, per minute. So I want to change it into revolution per second. And to do that, it will be 100, okay, it times with set per minute, so which means it will be 1 over 60, okay. And then the unit will be a revolution per second. Then 1.67 revolution per second. All right, and then our omega final, the angular speed for your final, is 0 revolution per second, so we don't need to change that. And then next we're going to convert our angular acceleration, which is equal to negative 1 radian per second square. I need to convert that into revolution per second square. So for this one, I just need to change the radian into revolution. I'm not going to change the time because it's already per second square. So to change radian to revolution, we know that one revolution is equal to 2 pi radian. So to change the radian into revolution, for that I'm going to use negative 1, you times with 1 revolution, okay, divided by 2 pi radian, and the unit will become revolution per second square. And for that it will be negative 0.159 revolution per second square. Now I already have all the infos, okay, and they share the same unit for the angle and also for the time. Next, I'm going to calculate the first question, which is question A. It said calculate the time required to stop the flywheel. So to find the t for question A, I'm going to use the first equation, which is omega final is equal to omega initial plus alpha and then t. As we know from the previous, we already have these three infos, which is we have omega f, omega I, and also alpha. Then we just substitute. So omega final is 0, omega initial in revolution per second is 1.67 plus with your alpha, this now is negative 0.159, and then times with t. So from there we can calculate t is equal to 10.50 seconds. So that is amount of time taken for the flywheel to stop, starting from 1.67 revolution per second to 0 revolution per second. Next will be question B. Calculate the number of revolution made by the flywheel before coming to rest. So the question asks about theta. So to find theta, I'm going to use the second equation, which is omega final square is equal to omega initial square plus 2 alpha and theta. So theta is number of revolution. And then your alpha just now is negative 0.159. And then we have theta. So what would be the theta? Number of revolution. So the number of revolution is equal to 8 revolution. So that is number of revolution made by the flywheel before it coming to rest. So next will be question number 5, and this will be the final question for today. So question number 5, a car accelerates uniformly from rest and reach a speed of 22 meter per second in 9 seconds. Assuming the diameter of the tire is 58 centimeter. Question A, find the number of revolution the tire makes during this motion if no slipping occur, and what is the final angular speed of the tire in revolution per second. Okay, so question A, how many revolutions? So clearly the question asks what is the theta and what is the final angular speed. So which mean will be omega final. So that is question A and question B. So we try to find what is the info. Now dekat soalan ini dia provide kita punya info di dalam linear motion. Okay, a car accelerates uniformly from rest. So I can say that your u is equal to 0, start from rest, meter per second. And the reason why it is not omega, because the car is not rolling, dia tidak berpusing kan, so dia bergerak secara garis lurus. That's why we put as u lah, not as omega. Okay, and reaches the speed of 22 meter per second, which means finally it will reach the value of the final speed, which is equal to 22 meter per second, and the time will be t is equal to 9 seconds. Okay, so for question A, I'm going to use the info given, the infos that given u, v and t, which means from there I can use the first equation of linear motion, which is v is equal to u plus at. The reason for that, because I want to find what is the acceleration first. So we have 22, u is 0 plus with a, time is equal to seconds. So your acceleration is equal to 2.44 meter per second square. Alright, so from your acceleration, I can find what is the linear displacement, which is I can use equation v square is equal to u square plus 2as. So your v now is 22 meter per second, and then square u is 0, start from rest, plus 2, and then your acceleration is 2.44, and then your displacement s, so displacement will equal to 99.18 meter. Right, after I found the linear displacement s, I'm going to use this value to find what is number evolution. So there is one equation that relates these two displacement, which is linear displacement s and also angular displacement theta, which is the equation will be s is equal to r theta. So from the question also, we are given that the diameter of the tire is equal to 58 centimeter. So that is basically to find what is the radius, okay, which is the radius will be diameter you divide by 2. So you have 58 centimeter, I change into meter, you divide by 2, and then you will have 29 times 10 to the power of negative 2 meter. So I change in meter. So s is equal to 99.18 meter. Your radius just now is 29 times 10 to the power of negative 2 meter, and then our number of revolution. So theta is equal to 342, and the unit will be radian. But the question asks about number of revolution, and the answer that we get just now is in radian, so I need to change that into revolution. Okay, number of revolution, and for that it will be 342 radian. You times with 1 revolution is equal to 2 pi radian, so that will be 54.43 revolutions. So next will be question B. What is the final angular speed of the tire in revolution per second? So we want to find omega final, and specifically the unit is revolution per second. Baik, untuk soalan B, saya akan gunakan equation daripada angular kinematics juga. Baik, tadi kita dapati bahawa kita punya initial u is 0 meter per second, and then kita punya v, your final speed, is equal to 22 meter per second. Alright, so this v, your final speed tadi sebenarnya kita boleh tukarkan dia kepada omega final, and the equation that relates these two, v is equal to r omega, and then that will be final. Okay, so v is 22 meter per second. Your r just now is 29 times 10 to the power of negative 2 because it is in centimeter, and then our final angular speed omega f. So from there, omega f is equal to, so you will have 75.86. Okay, the unit is radian per second. Okay, but now it asks the unit in revolution per second. So I need to convert this, of course, from radian per second to revolution per second. And to do that, I'm going to times with, okay, we know that for 1 revolution it will be equal to 2 pi radian. So for this one, I'm going to times with 1 revolution and then divided by 2 pi radian to cancel out the radian. That will give us 12.07 revolution per second, and that will be your final angular speed unit in revolution per second. Okay, so with that example or with that solution for question 5b, I think that's all for our session today. Thank you very much for your attention. I'll see you next time. Assalamualaikum warahmatullahi taala wabarakatuh.